Hello, Carly Solelli here. In this video, we're going to look at classes. Classes are another very powerful feature of any object-oriented language. In this case, PowerShell, but also in languages like C#, Java, C++. They all have something known as a class type structure. Even the old C language used to have structures, and that was sort of the primordial idea of a class. Okay, you could almost think of a class as an extension of a function. So if a function can combine hundreds of lines of code, sort of like a to-do list in code of something, and you can recall that function, that module over and over, well, you could think of a class as, sort of building upon that idea of a function. So a class it's not just a to-do list like a function, but it's also, a class is both a collection of things that an object does and things that an object is. So a class has data members or variables, but a class also has member methods or functions, and all of these are associated with that class. And there are several other concepts that we'll take a look at, such as inheritance. So you can create or write a base class, or what's known as an abstract data type, and you can derive or inherit from that base class with child classes, with derived classes. And this enables you to write very complex applications and software using a lot less code, because you can reuse all the code from the base class. So I might create an abstract data type, or I might create a base class and add all this code, hundreds or even thousands of lines of code. And then I can create child objects from that class that differentiate or that I modify for my particular needs, but they can use all the code they inherit from their parent object, from the base class. So we'll look at these concepts. There's polymorphism, there's inheritance, there's abstract data types, base classes, instantiation. Just, again, very useful objects in PowerShell that will allow you to hopefully create more sophisticated and more powerful scripts with less code and less effort and more versatility. In this video, we're going to take a look at classes in PowerShell. And classes are a structure and feature of any object-oriented language. And PowerShell in its early days, I guess you couldn't say it was truly object-oriented. They didn't really have a class structure in the early days of PowerShell. But I believe it was PowerShell 5 where they introduced classes. I could be wrong, I'd have to Google that. But at that point, though, PowerShell did basically become a true object-oriented language. And we've already done a couple of videos on functions and how that helps you write modular code. Well, a class is a further extension of the idea of a function. Okay, it's kind of like a next level function, or a way to further modularize your code. There are several key concepts that go with classes, and when a language supports classes, it's a true object-oriented language. Okay. So the idea behind a class, it encapsulates something that is called an object, okay? And an object, that's an instance of that class. So you can think of a class as a blueprint, okay? If I were an architect, I could design beautiful buildings and beautiful homes and create blueprints. And those blueprints would have all of the information and the data necessary to build a building or to build a house, but the blueprints themselves don't do anything until you actually construct the building or construct the house. You'd have to hire a construction crew, and then they would read the blueprint and they would build it out of material and actually construct an object. So that blueprint would be used to build an actual building or build an actual house, okay? Well, a class is a structure in a programming language that lets you, the programmer, create your own object. All right, so you have all these built-in objects in PowerShell we've been using, like integers and doubles and strings and arrays and array list objects. Well, with a class, you as a programmer, you can create your own objects. So you can make an employee data type. You can make a dragon data type, a unicorn data type, a student data type, you know what I'm saying? A clock data type. So the idea behind a class is it lets you build a blueprint in code of a real world object. And so classes follow certain principles regardless of the language that they're in. So whether C++ or Java, or C# or PowerShell, there's still the same basic features or ideas behind a class. So again, think of a class as a blueprint where you as the programmer get to create your own data type. You get to be the architect, and then once you've written the class, you've coded it, it's a blueprint, then you can instantiate or build instances of that class of object, okay? And one of the key concepts behind a class is the idea of encapsulation. And by encapsulation, we mean that a class defines both what something is and what something does. A class defines what something is by the data members inside of it, okay, the variables. And a class defines what something does by the methods or the functions that are declared inside of it. Classes also, they give you a way to use your code in various ways and to reuse your code, even more so than functions, because with classes comes the concept of inheritance. So you can create what's called a base class in PowerShell or Java or C++, an abstract data type. And you can put code and functions and data members inside that base class. And then that can be like a parent type object. And then you can write child objects that inherit from that parent object. And that parent object might have hundreds or even thousands of lines of code. And when you create a child object that inherits from the parent, you get to reuse all that code without having to reinvent the wheel, or without having to recode everything needlessly. So again, the class idea, with its encapsulation, with its inheritance, it's very powerful, right? A very powerful and efficient way to code something, especially when your projects get larger and more complex, okay? So let's take a look at a basic class, okay? And in this code here, in PowerShell, you're going to have the keyword class and then the name of the class, okay? So, matter of fact, let me make this a little bit larger. There you go. Now you guys can see. All right, so this is our monster class. And inside the class, I've declared some what are called data members, okay? Data member is just a variable that's declared inside of a class. And in addition to the keyword class, a class has open and closing braces, just like a function. Do you begin to see the similarities? Remember when we went over functions? They always begin with the keyword function, and then the function name, and they have open and closing braces. Well, a class begins with the keyword class. It has the class name and open and closing braces, okay, curly braces. So, in this case, we've declared 4 variables in line, meaning inside the class. And these variables would be considered data members of the class, okay? So remember what we said, that, like a blueprint, when you write a class, when you code a class, it doesn't do anything. It's inert. It's the blueprint to build something, but it can't do anything until you actually build an instance of the class, right? Until you instantiate that object. And there are several ways to do that. So in this first example, this first function here, we're going to build a monster object. And the way you do that, you take a variable, any variable, And I'll just to show you that they're different, I'll rename this monster1. This monster here is different from the monster class, and I don't want to confuse you guys, so I'm going to rename these just to just to illustrate the point, okay? So we don't want to get confused with the class definition, the blueprint, versus the class instance, the actual object built from the class. So I could do that. I could give it the same name because of scope, right? PowerShell sees this inside of a function, and it knows that that's a variable, and it sees this as the name of a class, and it knows the difference, but it might not be as clear to a human, so just wanted to rename this. All right, so monster1, I'm going to use this method, the new dash object method, to instantiate or build an instance of my blueprint, okay? My monster class. And then when I do that, I can use the dot operator. And any data member that is declared inside of a class, it can be accessed via the dot operator in any function or method. And at this point, if you have used commandlets, PowerShell commandlets, you may begin to recognize the structure now. When you use a commandlet, a lot of times you're using a class, all right? And you'll notice those commandlets, they have methods and functions available to them. And they have data members, okay? So a lot of them would be a class type object or a class type structure. And encapsulated in those commandlets are a set of attributes, variables that you can set and change, get and set, as well as functions or methods in that class of object. So understanding classes, it'll not only help you create your own data types and code your own blueprints for your projects, but it will also help you understand at a deeper level commandlets and how they work and what's going on behind the scenes and under the hood with PowerShell, okay? So you'll recognize this syntax, right? A lot of times when we implement or use commandlets, we use the dot operator to access their data members. Well, in this case, we've written our own class of object and we've instantiated it, we've built it here, and we're going to use the dot operator to get at these data members in the class, right? So there's a string, generic monster, health, attack, and defense. And we're just going to call with the dot operator. Now, in other languages like C++ and Java, it's common to you make the data members private inside of a class, okay? You protect them. You don't allow them to be accessed directly the way we're doing it here in PowerShell. And then you write a whole series of functions, get and set. And your get functions simply return the value of the private data members. And your sec functions simply set the value of the private data members, okay? And you can also see that in PowerShell. When you use a commandlet, a lot of times don't you find there's always a set method and there's always a get method, right? Get dash and set dash, okay? So this is going to help you understand at a deeper level how commandlets function and what's going on, the structure of the commandlet itself, because it follows a lot of the same concepts of a class, inheritance and protected or private data members, and a get method and a set method. There's always a get and there's always a set. And there would be with every class and there would be with every commandlet, okay? All right, so let's run this first example. We'll move it over to test here and see what this code does. All right, so we need to call our function or invoke it. So I'm gonna add a line down here to invoke our function. Don't need a semicolon, but force of habit, because I'm used to Java and C++, and you terminate a statement with a semicolon. What I like about PowerShell, you can use the semicolons and it doesn't hurt anything. And that way when you go back and to other languages that require the semicolon, you don't have to worry about forgetting it. But it's up to you. All right, so if we run it, notice that it says instantiating a monster object using new object, okay? And that's just here inside this method, create monster1. But what happens is when I use the new dash object method and I build or instantiate a monster object, it calls a special function inside the class called the constructor. Now, every class that you write, that you create, will have a special function called the constructor that's always the same name as the class. Even if you don't define it, it's there. There's a default constructor. But you can override that. And by overriding that, meaning you write a function with the same name, but it does your own thing. So a lot of times you want certain things to happen or certain things to be initialized when an object is built from a class. And so if I wanted to, I could write my own constructor for monster. But in this instance with new object, I'm just using the default constructor, which does nothing. Doesn't display anything at the console. A couple of examples from now, we'll take a look at writing our own constructor, okay? And again, once I've built monster1, I can get at all the data defined in line inside my class by using the dot operator, okay? All right. Now let's take a look at our next example, okay? And in this case, when we finish renaming this monster2, all right? This is just an example of another way that you could, and actually, let me keep the class there, and we will replace the function or the method, okay, there. And if this makes it clearer, I'll add comment tags there, okay. And we just want to invoke that function, okay. So this is just another way of doing the same thing. I always like to give you guys options so you can kind of develop your own style and your own method of doing things. But personally, I prefer this method. I like to use the new object method, but if you want to, you can also instantiate or build a class object this way. And what does this look like? Typecasting, right? Where you cast one data type to another. So in the square brackets, we have a monster. That's our class of object. And here we're scoping into it as if we're parsing and just calling the new method. But just to show you that this does the exact same thing, let me clear the console and we'll run it. And see, it does the exact same thing. It's just accessing the inline data members of our monster class with the dot operator. But instead of using new dash object, we used the new method, all right? And the name of our class goes in square brackets. So options, preferences. We're going to develop this idea of a class a bit more, okay? So here in this class, we're adding a bit more. And we have a monster class as we did before. And this time we are basically, we're creating our own constructor, all right? And in this constructor, there's certain things that we want to happen when we build a monster. So we want to give the initial value of generic monster for the monster's name. And we want to initialize health to 100, attack to 7, and defense to 12. Also, when I'm inside of a class and I modify the value of something, I have to use what's called the this operator, okay? Or in C++, it would be called the this pointer, but basically it's just a special object that points to the internal object itself in memory, okay? And, we can call it the this pointer if you want, or the this object, but so, my data members are down here: name, health, attack, defense. I have one string and 3 integers, right? But if I'm going to access these data members or assign a value to them, I have to access them via the this pointer, all right? The this object here, this operator, and then dot, and then the variable name, okay? So it's fairly straightforward, right? Just remember that you have to use this and dot to access the data members you define inside your class, okay? This is the constructor. Remember, the constructor always gets called automatically when you instantiate or build an object from the classes that you code. All right, so the class that you code is your blueprint. When you build it, you instantiate it. That's when you actually allocate resources, memory, CPU cycles, whatever that class needs to be brought into existence, right? To have an instance of that object manifest itself and be created. So the constructor can be very useful when you need to initialize a lot of values at an object's instantiation point or at its point of creation. Okay. Now, in addition to data members, you can have member methods, and they're just functions declared inside of a class. And the only key difference, notice that when I'm inside of a class and I write a member method, I don't have to use the keyword function like I do if I were outside the class, like here. See what I'm saying? Here I have to use the keyword function because this is a normal function. But here, and from this opening brace up here to this closing brace here, this is all the blueprint for my monster class object. So any function I declare in between these braces, I don't have to use the keyword function. And also, because I'm writing a method to display my monster, I want to display the monster stats, right? The name, the health, attack, defense. Once again, I have to use the this pointer because I'm inside the class itself. Now, when I'm outside the class and I've built an instance of the class and it is manifesting itself in reality and it's not just a blueprint anymore, then I don't need to use the this pointer. But when I'm inside the class, I do. So kind of file that in the back of your mind someplace, okay? So those are the changes inside our class of object. Now, when we get here, all right, we're going to clear the screen. We're going to use new object, and we're building a monster, okay? And again, PowerShell knows that this variable name that points to my new monster is different from this class monster. And if we were programming in a case-sensitive language like C++ or Java, then capital M, lowercase O-N-S-T-E-R would be different from all caps M-O-N-S-T-E-R, okay? But PowerShell is not case-sensitive, so again, I'm just now realizing that I probably gave you guys a bad example and this is confusing, so I apologize. So why don't I do this real quick? And that way it'll differentiate it from the class name. PowerShell still knows that it's different, but maybe to the human eye, it's confusing or does not. All right, so now that our blueprint's name is monster, but our instance name, right, the variable that points to the instantiated object, our instance name is monster1. So now we can easily tell the difference, okay? So whatever you're creating, dragon, unicorn, employee, student, widget, clock, whatever you want to call it, mailbox, whatever. But what I instantiate, what I build, what I create from my class blueprint here, I always assign it to a variable. And then once I do that, I use that variable and the dot operator to access all the data members here and all the functions, the member methods defined inside the class. So what's going to happen now when we build this class, you're going to see the constructor get called. It's always called automatically. And remember, the constructor is always, it's the only method that can have the same name as the class itself, okay? And anything you put here will automatically happen when that object is built and resources get assigned to it, memory and CPU cycles and such. So all this is code that, it will initialize every time a monster is built. So when this happens here, monster is equal to new object or new dash object monster, you're going to see the constructor get called. And the only way we'll know is it's going to write host instantiating a monster object. You don't have to do that, but I do that in all my classes, at least until I get ready, with the finished product, and then I might comment it out. But when you're debugging and you're working through logic areas and stepping through your code and trying to figure out, why is it doing this when you want it to do that? Or it can be very helpful to always include a line in the constructor of every class you write, just to output something to the console and let you know, hey, I'm building this object. I'm instantiating this object. I'm allocating resources for this object. That information can be very, very helpful when you're debugging your code. And then when you're done and you're ready to release your final version, you could just go in and comment it all out, you know? Or you could even add an if and else decision structure and use a Boolean to switch it on or off. Or try catch blocks, or, you know, there's all kinds of ways that you could do that, but just trying to give you ideas. Okay, so you'll see the constructor get called when we run it. And then we're going to call the display method. That's a member method, and it's accessed via the dot operator. Right? Here's the display method inside the class. And so are the data members, right? If I wanted to set or change the data members, now I'm going to change its name from generic monster, which it was initialized to be evolved generic monster. And I'm going to increase its health, right? Its health was 100. Now it's 200. And its attack was 7. And now it's 15. And its defense was 12. And now it's 25. Right? So I'm going to make those changes. And again, notice I'm doing that with the dot operator. Okay? And then I'm going to call the display method again. And that'll show the changes. So the first time we call display, it's going to show us the default initialized values, you know, what they were initialized to when the constructor was called, when we built or instantiated the object. But the second time we call display down here, you'll see the effect, or you'll see these changes being reflected when we call this member method here, which simply displays all the private data members. Well, the private, I'm thinking it's supposed to say, simply displays all the data members in our class. Okay, so we're going to run this function. Let me clear the console output here, and we'll run this method. I'm going to hit F5. So here's the constructor, right? Instantiating a monster object. And these are the initial stats. So if we go over here, see the code in our constructor? These are the initial stats, okay? And after we built our monster and instantiated it, and we call display, well, the first time we call it, it's just the initial values as they were set up in the automatically called constructor method. But then we change them. We change them all using the dot operator and the member methods. And then we call the display method again. And boom, here are our changes. See? And again, if you're familiar with using commandlets, you will begin to recognize that this is the way that all commandlets work. They follow a very similar structure where encapsulated within the commandlet are data members, right? Variables that you can set and manipulate and change and get. And there are methods and functions that are all sort of encapsulated in that commandlet. Okay. Let's take a look at our next example. And I'm going to clear the console again. Okay, now, in this example, we're going to introduce the keyword static, okay? And when something is static, okay, the thing is, normally when I build or instantiate an object from a class, every single object I build, every single object that I instantiate has its own separate set of data and methods, okay? So the values can be different. If I built 100 dragons and the data wasn't static, if it was just a normal data member, like the previous two classes that we defined, then every single one of those objects could have its own set of values, different and separate from all the other objects. A static variable is different, however, because even if I built 100 objects, say I had 100 unicorns from my unicorn class, or 100 monsters, or 100 employees, or 100 students, or 100 dragons, if I declared data to be static inside a class, that data would be the same for every single one of those objects. And I just saw an extra semicolon there added by mistake. But that data would be shared among all instances of a class. Okay, so that's one key difference when you see the keyword static. And another key difference is normally I have to instantiate or build an object from a class before I can access one of its data members, okay? If I tried to access a data member from a class blueprint without calling a new object or the new method and building, instantiating it, it would be a syntax error. PowerShell wouldn't let me do it. But when a data member, when a variable is declared as static, I can actually access that variable directly, even when an object has not been built from the class, even when an object has not been instantiated. I can actually get at the blueprint data itself instead of the object built from the blueprint, if that makes sense. And so there are reasons to do that sometimes in your code. I don't use static variables a lot, but there are reasons. Sometimes you want all instances of a class to share the same data, constant values and things that don't change. Or sometimes you want to put things into a class and use it as a way to organize your code, but maybe you're not necessarily planning on building an instance from that class. Or at least maybe you want the option to access certain pieces of data members directly without having to instantiate objects of that class. So there are reasons, okay? So let's see what happens. We have a default constructor here, right? Same name as a class, always the same name as a class. It's just going to display instantiating a monster object in the console. And again, you don't have to do this, but it's a good idea. It will help you immensely when you have, large scripts, hundreds of lines or thousands of lines of code, and you have lots of classes and things. It can really help you track issues and problems down just by adding one simple line to the constructor to let you know when an object is getting built, when an object is getting instantiated and resources are being allocated to it, okay? So in the function createMonster, we're just going to say we can pull static data directly from a class. And one of the key differences is notice the way we access it. When we access a data member from an instantiated object, right? An object that has been built from a class, say using new-object or the new method, we'd use the dot operator to get at that data. But when we declare data to be static within a class, then we use this double colon structure here to scope into it, to access it. And we use the name of the class in square brackets, okay? Almost like we're typecasting. Kind of looks like, remember when we went over that video on data types and we talked about converting one data type to another? Almost sort of looks like that, doesn't it? And then I make the point. Notice we never built a monster object. This would never work if these data members weren't static. PowerShell would be like, what the what? PowerShell would say like, no way, I'm not going to let you do that. You need to build a monster before you can access the monster's name, health, attack, defense. But this is the exception to the rule because, and only because, we declared these data members to be static, okay? So, if I were to run this, boom, we can pull static data directly from a class without instantiating it. Here's our static data, and we never even built a monster, right? That was just data pulled directly from the monster class, the blueprint for a monster. So that's the exception to the rule. But generally, you're always going to need to build and instantiate an object from classes that you create, that you code, before you can use them or access their data or their methods. Let's take a look at another example. And in this case, we're going to go over the keyword hidden. Now, in C++ and Java, remember what I said? It's very common to make all of your data members, your variables, protected or private. And you tightly control access to your member data. You don't allow it to be accessed directly. What you do instead is you make your data members private or protected, and then you create public, what are called accessor methods. And the accessor methods always, you have a get and it always returns a value, and you have a set, and it always sets a value. And don't you see that in PowerShell? Don't you see that in commandlets, right? You have all these commandlets, and get dash in a commandlet, or set dash in a commandlet. Well, that's carried over from concepts that were introduced in C++, which might be considered the first high-level, truly object-oriented language. And then later Java, which came after C++. So that concept of get and set and having public accessor methods and making your member data private, okay? Well, in PowerShell, you have something that's somewhat related, not the same thing, but somewhat related. You have the keyword hidden. There's that double semicolon again anyway. All right, so we're going to go through and look at a couple of examples here. First thing we're going to do is a visible monster, okay? So let's copy our visible monster over here to our test. Okay, so we run a class visible monster. We have a constructor, right? It's going to display this to the console, and we have some data members, okay, 3 data members, and we have a member method display monster, okay? There's our display monster. It's just going to display those data members using the this pointer. Say that 3 times fast. The this pointer, that's 2 th. It's really hard to say. Okay. Okay. So anyway, Peter Pepper picked a peck of pickled peppers. Pablito clavó, clavito que clavó, Pablito. Pablo plays the clarinet. Which squirrel? Okay, sorry. All right, back on task. Sorry, my ADHD. Okay. Tongue twisters are fun, right? Okay. In this case, this is a non-hidden class. Our data members are not hidden. So we can access them with the dot operator, right? Once we instantiate and build our monster object, and I did that same thing. Again, PowerShell knows that this variable that points to our instance of monster built from the blueprint of visible monster is, oh wait, what am I saying? I forgot, I already renamed that. Oh gosh, it's 2 in the morning. I'm cracking up. Okay, I'm getting loopy. I feel pretty loopy. But anyway, all right, never mind. So it's not confusing. All right. Yeah, I forgot I already changed the name of that. Okay, cool. So this is our visible monster. All right, so monster's different. So good. So I just want to make sure that's not confusing. Remember, if I wanted to, I could call the name of my class monster, and I could also call the variable that accesses my class monster. And PowerShell knows the difference, but you probably don't want to code something that way because it could end up being confusing. Eventually, you might, is that the blueprint for a monster? Is that an instance of a monster? So maybe it's good practice to always give it, give it a different name. Anyway, monster is a variable. It creates a visible monster. We're setting the data like we always do with the dot operator, and we're going to call the display monster method. Okay. Now, there is a function called getMember, and it will get the properties, the data types defined inside of a class, okay? So we're going to call that, and it works with the pipe symbol and the class instance. So we're going to call getMember on monster. We'll just show you what a normal class looks like, okay? So I'm going to run this. Oh, and let me invoke the function. I'm so loopy tonight. All right, let me invoke the function. Okay, so invoke the function, and note that we can set and get values of an instantiated object when it is not hidden, right? So we're calling display monster. Display monster is inside the class. It just displays all those data members. And you can see that here, right? And you also see the constructor being called. When we build or instantiate a visible monster, it calls the visible monster constructor and displays instantiating a visible monster object in the console. And then down here we call getMember, and notice when we call getMember, you can see the data types, integer, string, attack, health, and name respectively. Okay? So that is a non-hidden set of data members in a class. Now, let's make a new class. We'll call it hidden monster. And this is going to use the keyword hidden with our data members. And I'm going to throw this over here. Okay. And same thing with our constructor, right? But now we're instantiating a hidden monster object instead of a visible monster object. Display monster does the same thing. The only real difference is these variables have the keyword hidden, right, in front of them, or prefixing them. So they're hidden. You know, these are sort of protected variables. We can set them, we can get at them. Another key feature too, autocomplete, the IntelliSense or autocomplete in ICE, and a lot of other IDs. There's that darn extra semicolon again. If a variable is not hidden and you hit dot, you can get autocomplete to bring up the data members of a class. But when a variable is hidden, it won't, unless you're inside the class. And that's the key difference. Okay, so like for instance, here I'm in the constructor, and so notice if I hit the this pointer, then all of these pop up: attack, health, name. I get, you know, because I'm inside the class, I can access the hidden data. But if I'm outside the class, I'm going to go in this function here, and let me do it after I did. So after I build my monster, if I wanted to try to access that data, I can't. I can access the method display monster because it's not hidden. But notice none of these data members up here, name, health, attack, and the class, they don't show up in IntelliSense, right? Now, if they weren't hidden, they would, okay? And here, I'll do this. I'll take the keyword hidden out of here. Okay. There, finally. Oh my gosh, it's like pulling teeth. Okay, I finally got ICE to show you what I was talking about. All right, so see, now that they aren't hidden, now they display. Okay, another key difference. I mean, when a data member or a variable is hidden, I can assign values to it using the dot operator and retrieve its value using the dot operator, provided I know the name of that variable or that method. But if I were to call getMember, it's not going to display anything unless I use the force option. So you'll notice when I call getMember without the force option, it's not going to show me the variables or data types. But when I use the force option, it will show me the variables and the data types. And again, the purpose of hidden is to be able to create classes and objects that people can use without necessarily knowing how they work, okay? Or to give you the ability to keep certain techniques, data, out of their prying eyes, shall we say. So if I run this, okay, notice with the dot operator and the constructor, it works just like non-hidden data members. But when I call getMember without the force option, we get nothing. No data types, no variables. Only if I use the force option do I get those variables. Okay? So I want to make another point about how classes basically illustrate the structure of almost every single commandlet in PowerShell. And so what I've done, I've rewritten the hidden monster class, and we've made our data members hidden. So if this were like C++ or Java, they'd be made private or protected data members, okay? We would not allow direct access just using the dot operator to get to name or health or attack, okay? We would not allow that. Rather, instead, we'd make all our data members private or in PowerShell hidden, and then we would create public, what are called accessor methods, okay? And these public accessor methods, they would be used to get at this protected, private, hidden data, okay? So, in other words, to access name, I'd have a get name and a set name. And to access health, I'd have a get health and a set health. And to access attack, I'd have a get attack and a set attack, okay? And The logic, okay, syntactically, it's the same for every get and every set. So every get just returns the private data, and every set just sets the private data. So it'd be coded a bit differently in C++ or Java, but in PowerShell, the way that I would do that, I'd simply use the keyword return if I call the get accessor method for get name, and I want to return using the this pointer, this.name, okay? For health, I'd call get health, and I want to return this.health. And for attack, I'd call get attack, and I want to return this.attack. Remember in the videos on functions where we went over functions with return values and advanced functions? That's all this is, okay? And I have to set my return type. So I'm returning a string with this get, and I'm returning an integer with this get and with this get down here. So gets always return a value. They're just very simple functions that are made publicly accessible inside your class to get at hidden or private data, okay? Now, in the same way that every private data member would have a get accessor method, it's going to have a set accessor method. And in the same way that the get always returns a value, the set always takes an argument or a parameter and sets a value. So I have to, again, declare the data type. I take a string, and I'm going to take what I pass in. Remember what the assignment operator says? Take what's on the right and store it in what's on the left. And oops, I left a dollar symbol out there. I have a problem. I would have had a problem with that. There, okay. All right, so I take what I pass in, and I set it to the private data. All right, that's for set name. Set health does the same thing, although instead of a string, I'm taking an integer as a parameter or an argument. I take it in on the right, and I store it, or I save it in what's on the left. So I'm setting. Same thing for set attack. I take another integer argument. It comes in, and this is my public set function, and I set my private data. So public get, public get, public get, public set, public set, public set, to access, to both get and set and manipulate this private data up here, okay? So believe it or not, under the hood, behind the scenes, that's the typical structure of almost all the commandlets in PowerShell that you're utilizing. That's why you see all of these get methods and all of these set methods. Those are accessor methods. So hopefully that demystifies things a bit. All right, so what are we going to do with this class? Well, we're just sort of illustrating the process. So we're going to say at the console, let's build a monster. We'll access its data members using accessor methods, right? Public accessor methods. That's these here to get at this hidden, private, protected data here. I'm mixing PowerShell, Java, and C++ keywords all together now. This is how data members are accessed in C++ and Java. Their member data is always private, protected, or hidden. Then you code public accessor methods to access the private, hidden data. You can see this get dash and set dash structure in PowerShell commandlets. And I'm just using foreground color here to change the color, so hopefully we don't get too bored. Add some color to our console output. It's still not glorious 3D graphics or anything, but just in case we're getting tired of the same color. Okay, now PowerShell uses the dash with its get and its set accessor methods. Now, that's a reserved character, and I'm not allowed to do that in my own functions when I'm writing my own member methods inside of class. So what I did instead is I just used the underscore. But if it were allowed, it's not, PowerShell won't let me, but if PowerShell would let me, if I change that to a dash, see the little red squiggly? PowerShell says, you can't do that, that's reserved. But that's a commandlet, right? A get dash commandlet or a set dash commandlet, like get mailbox or set mailbox or get remote mailbox or set remote mailbox or, you name it. There's so many hundreds, if not thousands, of gets and sets in PowerShell. And so now, because you're beginning to see how classes work, because you're kind of developing a concept of classes, now you understand how commandlets work. You see what's going on behind the scenes, right? So again, this is the C++ and the Java way of doing things, and it's also the PowerShell way of doing things. It just kind of hides it from us. So instead of using the dot operator and accessing this data directly, this data is protected. This data is hidden. So I could have a whole bunch of classes potentially with data hidden away from prying eyes, from thieves and vultures. What's that Sarah McLachlan song? Vultures and thieves at your back, whatever. But I'm saying, if for some reason there were certain, maybe there's certain procedures I don't want people to see, or data members I don't want people to access. Doggone it, there's that double semicolon again. Gotta get rid of it. But I want them to be able to use my class, my object, my functions, my methods. I just don't want them to see the internals. Well, I could make my data members hidden and then offer public accessors to access the data. So again, instead of accessing the data with the dot operator directly, I'm going to call the public accessors. I'm going to call set name, pass in Bubba, set health, level 9,000, and set attack 444, okay, which is the number that has been haunting me most of my life. I don't know why, but then when we want to get the value, same thing. We're not going to access this private data, this hidden data directly. Thinking C++ here, but we're going to use our accessor method, get name, get health, get attack, and it just returns the value, okay? And so if I run this, let me pull this out, and I'm going to change directory here so I have a little more space, okay? And you can see that essentially, yes, we are accessing this. Let me pull this over here. Essentially, we're accessing all this private data right here, right? No problem getting to it. But we're getting to it through public member methods to get at that hidden data, okay? And, that with PowerShell scripting, it's hard to say when you might need that, but at least it's available. It's there for you when you need it. And that may also help explain to you why commandlets are structured the way they are. Why do they always have a get dash or a set dash? So again, just to illustrate this point or further elucidate it, if I call get, right? See? Look at all of the get methods I have available to me in PowerShell. And so for instance, get mailbox. Okay, if I want to get my mailbox, okay, and then I can get my mailbox. And if I call set, look at all of the set methods available to me in PowerShell. And this is just a remote shell to Exchange Online in O365, okay? So I'm connected, but I get all of these commandlets in my connection in this module, right, in the Exchange Online module. And they've all got accessor methods. They all have a get, and they all have a set. Like, look at all these gets. So just kind of knowing this in the back of your mind, it kind of gives you a deeper understanding of how commandlets are structured. So basically, these are these get dash methods, right? They're accessor methods, and they're retrieving for us data members from the commandlets. Okay. It's a public way of accessing private, hidden, or protected data. And the set, right, it's a public way of setting that data. And this is just a shell if I do get PS session. This is just a connection I have to Exchange Online. See? Okay. In this example, we also have a monster class. This time we're just going to build a Godzilla, okay? So in the constructor, right, always has the same name as the name of the class that we coded. We're just going to display in the console instantiating a monster object. And we're going to initialize these data members to generic monster 107 and 12 respectively. Same thing, we have a display method. It uses the this pointer and displays the data, all right? Displays that class. All of its stats, name, health, attack, defense. We have these data members here, okay? we're going to build an instance of the class down here, but we're doing something different here. And this illustrates the concept of inheritance with classes. All right, so you can create a base class or an abstract data type, but then you can create a child class that inherits from that base class, an abstract data type, and the child class is a more specific blueprint, right, or type of blueprint for a type of object. And that sort of models the real world, right? Inheritance works that way in the real world. For instance, a base class or an abstract data type would be the automobile class, right? And every automobile has lots of things in common. 4 tires and a steering wheel and an engine and headlights and a horn and things like that. So all of that code, all of those structures could go in the abstract data type in the base class of automobile. But then there are more specific types of automobile, right? There are Fords and Chevrolets. There are Hondas and Toyotas, okay? And then there are even more specific instances of those. So, you have the Toyota Camry, different models of Toyota, okay? So does that give you an idea of what inheritance is? Inheritance is all around us. Inheritance hierarchies exist all around us in the real world, okay? Not just with automobiles, but think about an animal, right? I love cats. I'm probably going to die alone with my cats. But a cat, well, yeah, a cat's definitely a cat, but more generically, a cat is a mammal, right? And all mammals have certain things in common. So a cat would be built from the mammal class. It's warm-blooded, it's furry, it nurses its young with milk that it produces from mammary glands. All mammals have that in common. And so a cat would be a child class or a child object of mammal. And then mammal itself would be a child object of the animal class, right? The animal class could be a base class to mammal, and then mammal itself could be a base class or abstract data type to a more specific cat object. So the real world is full of inheritance hierarchies. And in PowerShell or C++ or Java, when you're using classes, it's no different. That's one of the key features or advantages of using classes is inheritance. So that's what we're doing here. In this example with the colon, we're creating a new class called Godzilla, and we're saying Godzilla inherits from the base class monster, okay? And that means that Godzilla, even though it's a completely different class, completely different blueprint, Godzilla gets to use all the data members and all the member methods and even the constructor of its parent object, okay? And I could have a dozen different levels of inheritance in my inheritance hierarchy. So I could have an entity class, and from the entity class, Monster could inherit from that, and then Godzilla could inherit from that, and then so on and so on and so on. So it's sort of the idea behind an inheritance hierarchy, but that gives you the ability to reuse so much of your code, right? Because any code I define here in the base class, in the ADT, the abstract data type, I can reuse all that code in child classes that inherit from that base class. If it weren't for inheritance, if it weren't for the object-oriented polymorphic structure of an inheritance hierarchy and a class structure and a modern programming language, I'd have to rewrite all this code over and over and over for every object that I built. But because of inheritance, good grief, I could build dozens of objects that inherit from Monster, and Monster could have hundreds of lines of code, or potentially even thousands of lines of code. And as long as I build my objects to inherit from Monster, they get to use all that code. They instantly gain access to all the features of a monster, all the functions, the methods, and the data members, okay? So does that hopefully illustrate why inheritance is such a powerful thing and such a useful thing? Why it can allow you to code, more sophisticated and larger projects and types of automation, but with less code. You're writing much less code because you can reuse everything that's in your hierarchy, in your inheritance hierarchy. Okay, so here's our base class, right? The parent. And here is our derived class, the child object, Godzilla, : that means it inherits from the monster class. So Godzilla has everything in monster, and it also has its own. Any data members, any functions or methods that we put in Godzilla, it would have access to that as well. Now, it doesn't work the other way around, right? We inherit things from our parents. Our parents don't inherit things from us. Unless you ask my daughter. She thinks differently about that, and she has a creative way of thinking. But normally, right, in the real world, we inherit from our parents. Our parents can't inherit from us, their children. So your inheritance hierarchy in code works the same way. Godzilla inherits from monster and can use all the data members and functions of monster, but if I built a monster object, it could not use any data members or functions that were declared inside the Godzilla class. Okay? Does that seem logical? I think so, right? All right, so I'm going to build a Godzilla. And this all caps Godzilla is different from this uppercase G all lowercase Oddzilla. Oddzilla, I like that. Ooh, that's what I'm going to do. I'm going to make this Oddzilla instead of Godzilla. That'll be fun. There we go. And that'll hopefully make that. So, PowerShell knows the difference. But human-wise, maybe that was confusing. I apologize. I tried to think up some good, straightforward examples, and I didn't always do a good job. And I see definitely there are things I could have improved in these examples. But hey, you're with me as I realize that. And it's almost 2:30 in the morning, and I'm making PowerShell videos. Yay! All right, so Oddzilla is the variable, right, that points to our instance of Godzilla. And we use the new object keyword, right? So this method, we instantiate, we build a Godzilla. What you're going to see, because I add this line into the constructor so that you can actually see when the constructor is getting called, what you're going to find out is whenever I build a Godzilla object, because it inherits from monster, not only is it going to call Godzilla's constructor, right, same name as the class, but it's also going to turn around and call its parent's constructor. Since Godzilla is a child of monster, it's derived from, inherits from monster. When we call Godzilla's constructor, you're going to find out that it also calls monster, the monster constructor. Okay, so you'll see that when we build our new Godzilla called Oddzilla. Why didn't I think of that before? Just not thought of it. Anyway, oh well. Okay, so we're evolving Godzilla. We're going to say Oddzilla. I just like that even better. That's fun. Oddzilla. Yeah. That's what I feel like. That's me. It's totally me. Okay. I'm strange. I'm weird. Squirrel. All right, so we're going to call the display method. Now, does Godzilla have a display method? No, it does not. But remember, it's a child object. It's derived from, it inherits from monster, and monster does have a display method. So this is to show you that Oddzilla, which is a Godzilla, can utilize its parent's display method in the inheritance hierarchy, okay? And then we're going to modify these data members. Now, do these data members exist inside the Godzilla class? No, they do not. They exist inside the class that Godzilla inherits from, the parent. But in our inheritance hierarchy, anything that monster has, Godzilla gets. Because we declared it to be derived from, to inherit from, to be a child of monster. And then after we set, change the values, we're going to simply display it here. All right, so let's run the code, see what happens. All right, notice that when we build the Godzilla, it calls Godzilla's constructor, but first it calls the monster constructor, right? So first we have a generic monster, and then because Godzilla is a child of monster, then we instantiate after the monster a Godzilla. And Godzilla gets all the data members and all the functions that its parent class monster has. All right, so that's the idea behind an inheritance hierarchy, and it's not such a foreign concept because, again, think about it. That's how things are in real life, okay? You have an automobile, you have more specific brands of an automobile like Toyota, and then you even have more specific instances of Toyotas, like a Toyota Camry, or I can't think of any other kind of Toyota, but you understand what I'm talking about. You have an animal, you have a mammal that derives from or is a child of animal, then you have a cat that itself derives from or inherits from mammal, right? So it's not really such a foreign concept. Inheritance hierarchies are how things work in real life, okay? All around us in our legitimate real universe, there are inheritance hierarchies, and that makes you wonder. As it's 2:25 in the morning, and I wonder, what if we're all living in a simulation? Maybe that's the reason why the universe is full of real examples of inheritance hierarchies, because we are all simulated beings living in a simulated universe constructed with code. I wonder these things late at night. You ever wonder these things? Okay, sorry. Back on task. I just wondering. All right, so hopefully that was straightforward, okay? So, let me clear the console. We're going to look at hopefully a more interesting or fun example here, okay? So, we have an abstract data type, right? What's called a base class, the parent object monster. We're not really going to build a generic monster. We want to build a more specific type of monster. But if we do this, we can reuse all this code, all right? And this is really not a great example, but a better example would be if this class had hundreds of lines of code or thousands of lines. And then it would be really, really evident the usefulness, the power of not having to reinvent the wheel, of not having to needlessly type a bunch of code repetitively over and over and over again, of being able to reuse all that code, all those data members, all those functions, because of an inheritance hierarchy, okay? So monster is our base class, our ADT, our parent. Godzilla is a child object, and we say it derives from, that is, it inherits from, that is, it is a child of the monster class, okay? So it gets all its data members, constructor, methods, functions, whatever we put into it, and in addition to that, it gets everything that its parent has as well, just like in the previous example. And we could put things here that were specific to Godzilla, like what's Godzilla's attack? I don't know, what is that, a lightning attack? It's not really fire, is it? It's like some kind of weird nuclear lightning or something. I don't know, but we could add a member method that was only specific to Godzilla if we wanted to, right? So nuclear radioactive lightning. It's something like that, right? That is Godzilla's, right? So, and this would be a member method specific only to Godzilla, right? And Godzilla would have this capability, and I don't really have code that does anything, but we'll just throw something in here. Godzilla. You know, whatever. L-I-G-H-T, let me spell that right. All right, so nuclear radioactive lightning, okay? That would be a function, a member method specific only to Godzilla. I gotta stop tapping the desk. I know that gets annoying. I'm sorry, but it's almost 2:30 in the morning. So now Godzilla gets all of its parents' functions, methods, and data members, in addition to its own, like nuclear radioactive lightning. specific only to Godzilla. Okay, so let's build in a Godzilla. We're going to build a Mothra too. Mothra also inherits from monsters. So in this case, we built a Godzilla and a Mothra with very little code because both of them were able to reuse all the code in their parent. So everything a monster is, both the Godzilla class object and a Mothra class object inherit that code. They get all that code in addition to things that are specific only to them. And I don't know, Mothra had some weird, crazy wing flap attack, right? The giant moth wing flap. I don't know what you call Mothra's attack, but like it was like a hurricane. Wing flap hurricane. That sounds more like a wrestling move or something. Remember Macho Man? Was it Randy Rick Savage? Yeah. Wing flap hurricane. Yeah. Okay, it's late. I'm freaking out here. Sounds like a wrestling move, but that's a Mothra move. Okay, let's just say it's a Mothra move. Doggone it. And Mothra flaps wings and makes hurricane attack. Whatever, just an empty. But so just to illustrate, right? So this is something only a Mothra class object can do. Wing flap hurricane. Yeah, wrestling move, Randy Savage. All right, and nuclear radioactive lightning. Maybe that's what the sound effect would be. Who knows? That's something only a Godzilla class object can do. But since they both have the same parent, right? They're siblings. Display and all these stats is something both a Godzilla and a Mothra can do. All right, they inherit from the same parent. Okay. So we have another function here. We're going to build a couple of monsters. And remember what we went over on scope? We have two globals. We have a monster 1 and a monster 2 that are globals, right? So in our create monsters function or method, we're going to build a Godzilla using new object and assign it to our global and display the stats. And then we're going to build a Mothra using new object, assign it to our second global, and display the stats. Now remember, in the videos on functions, if these were local and not global, we'd have a problem. Because once create monsters ended and the function terminated, if those monsters were local inside the function of create monsters, they would be destroyed. And the memory would be salvaged and cleaned up. But because we created two globals in our global namespace, even when create monsters ends, these two monsters, Godzilla and Mothra, will persist in memory. And therefore we can then use them in other functions. Okay? So it's important to remember that, whenever a function ends, if you declare a variable local to that function, then all the values are lost. Those objects will not persist in memory. Many times that's what you want. You don't want to make everything global because that wastes a lot of memory and a lot of resources. But sometimes for a very good reason, something needs to be global. When it needs to be passed around from one function to another, or when it needs to persist in memory. And when you can't always do it in an indirect way, like returning a value and catching it or something. So there are plenty of good legitimate reasons to use a global, but you obviously would not want to make everything global. So the rule you want to follow, make everything local that you can, and only make something global if you have to. That's a way to conserve resources. So we build our monsters, they're global, they persist, right? We have a Godzilla, we have a Mothra. We have another function now, MonsterCombat. And we're just going to cause these two monsters to duke it out, right? Godzilla and Mothra. They always fight in the movies. So monster battle, monster 2 name versus monster 1 name, all right? So Godzilla versus Mothra or Mothra versus Godzilla, depending on how we instantiate those objects and which global variable we assign to point to them in memory to access them. So once we call their names, we get their private name data, or the name data defined in line, and their parent object, the monster class. We're going to call the display method from their parent object, the monster class, for both of them, display their stats. we're going to generate a random number between 1 and 2. It's just a token cost, right? So, and then we're going to plug it into a switch statement. We assign it the chance, convert it to an integer because we've got to do some comparison, a little bit of math. We're going to switch on chance, and when we do that, just a coin toss. Who gets to go first? Does Godzilla get the drop on Mothra and he gets the first attack? Or does Mothra get the drop on Godzilla and she gets the first attack? You know, who knows? So, a while true loop. We're going to keep this looping, and while Monster 1, let's say Monster 1 is Godzilla this time, his health is greater than 0, and Monster 2, Mothra's health is greater than 0. Remember a logical and, both sides have to be true. So Godzilla's health has to be greater than 0, and Mothra's health has to be greater than 0. If either one of these becomes false, then either Godzilla has died, been defeated, and Mothra wins, or Mothra has died and been defeated and Godzilla wins. And then that becomes the exit condition where we want to break out of this while true loop here. Okay, down at the bottom. So from this curly brace here all the way to this curly brace here, that's the sort of the battle engine. That's the primary loop that keeps our monster combat going. So Godzilla's duking it out with Mothra, and Mothra's duking it out with Godzilla, and attack and counterattack and so forth, okay? Does that make sense? Okay, so we have a Boolean here if monster 1 turn. Well, that's just determined right here, right? Whether or not it's the first attack. So in the coin toss, right, our random number generated between 1 and 2. If, in this case, if monster 1 gets the first turn, say it's Godzilla, then we would just want to check, and again, we want to make sure that monster is alive. We can't allow that monster to attack anything if he's dead. So we're just checking for that here in our if block. Make sure the health's greater than 0. And then global monster 1, in this case, let's say it's Godzilla, attacks monster 2, which is Mothra. Right? If we pull that data attribute, that name data, we're going to generate some random damage. We're just going to call it get ramage. Blah, blah, blah. Stop, it's so late. I'm drinking coffee, and I think I'm just going to stay up all night. I'm just going to try to stay up at work, and I'm not even going to try to sleep, and I'm just going to be even more loopy and more dizzy and more crazy tomorrow. But anyway, all right, so we're going to call the get random method, and min damage and max damage, all right? So our values, and what are our values? So between 5 and 30. That's going to be the random damage that we generate between 5 and 30, okay? So Godzilla, hypothetically, or Mothra, generates how much damage? The random damage. The attack skills, well, that's sort of like combat experience, right? And that's from the parent or the base class object. So whatever Godzilla's attack skills are, we're going to add that, right? Append that to the random damage, okay? And then now the monster's opponent has a defense attribute. So while Godzilla gets to add his combat skill and experience, his attack attribute to the random damage, Mothra gets to subtract from that damage using her defensive capabilities, okay? So we're just kind of, calculating out the ultimate or final damage once we add attack for the attacker and we subtract defense for the defender, okay? And then we'll display after the final attack. And this is just so if damage is less than, we don't want a negative value, right? If it's 0, then in this case, hey, the opponent's dead. But other than that, yeah, okay. So if it's -1 or -5 or -2, whatever, then effectively it's going to be 0. Okay, does that make sense? We just want to prevent negative damage to the health of the opponent. Okay. So, and then finally monster health. So monster health is equal to health minus damage. We're just subtracting the damage from whatever the current value of the opponent's health is. Okay. So again, if monster 1 were Godzilla, we would say monster 2 would be Mothra, okay? And health is equal to health minus damage, okay? And we don't want to subtract a negative value for damage. So if, let's say Mothra's defense was totally freaking awesome, and you know, Mothra's defense, and let's say that Godzilla was having a really sucky bad luck day, and even with this added attack, you know, Mothra was able to turn that into a negative value. Well, we don't want to plug that into our attack algorithm, because that would actually start adding, you know, more points to Mothra. You know, if minus a negative value is the same thing as addition, right? Adding. So we need to provide for that contingency. We need to code a little bit of logic here with an if block and say, hey, if it's less than 0, if it's a negative value, then just make damage 0. Because if we let it become negative, it's actually going to add health to Mothra. And that's not what we want, right? I mean, Mothra might be lucky. She might defend herself. She might not get any damage. But she's not going to get better. You know, she's not going to be healed because Godzilla attacked her, right? That's not meaningful. So we don't want that. We don't want a negative value there. And likewise, we could do the same thing with health, right? It's potentially possible that Mothra, let's say Mothra has 7, and after it's all said and done, Godzilla generates 13 damage. Well, then Mothra could end up with a negative value. You know, she'd no longer be greater than 0. She'd be less than 0. So she's like -5. So we could also add another if block here and do the same thing with health and say that if Mothra's Monster 2 health, you know, minus the damage is less than 0, then simply set Mothra's health to be 0, okay? And we'll do that. We're going to look at a couple of examples, and we'll go over that, and we'll actually do that. We'll see what that looks like in code. But I'm trying to keep this video down to an hour, I hope. At least the first introduction to classes video. There will be more in projects and things. Okay. Having stepped through all that code, I don't really need to cover this block, because this block is just doing the same thing, but the logic is inverted, okay? So everywhere opponent was here, attacker is here in this else block. And everywhere attacker was here, opponent is here. So we're doing the same thing, but it's just inverted, okay? And then notice that we're toggling this on and off. If, you know, Godzilla got the drop on Mothra and it was Monster 1 turn, you know, he won the coin toss. The coin toss. I can't talk. If you won the coin toss, then we're going to set it to be false. And so that way the next time we iterate through our while true loop, instead of this block being executed, this block will be executed. And if we do that, then what happens? Attack, counterattack, attack, counterattack, attack, counterattack. You see how that works? And when we get to the bottom, regardless, we're just going to display the health for Godzilla and Mothra, Monster 1, Monster 2, and we're going to pause for 4 seconds. Let's just sort of add a little bit of drama, you know, a dramatic pause to our attack sequence. I don't know, I mean, how exciting can it, you know, text in the console be? But hey, we're learning PowerShell, and hopefully we're having a little bit of fun with it. All right, so we just need to invoke our methods. We need to create the monsters, and we need to lock them into combat. So are you ready? Here we go. I'm gonna run it. All right, so instantiating a monster object, instantiating a Godzilla object, and we set the stats, and then instantiating a monster object, instantiating a Mothra object, right? So in our inheritance hierarchy, we built a Godzilla, and we built a Mothra. We set the stats. Now enter to continue. Well, now that we have built those objects, right? Read host. It's just pausing our program flow. We don't care about the value. We're going to assign it to null. Get rid of it, throw it away a bit. But at least we're catching that flying baseball so it doesn't break a window. We're just going to hit enter. And when we do, in program flow, what's the next thing that'll happen? It'll flow right into the MonsterCombat method. That's the next function invocation, or what we invoke in our call list and our invocations. So first create the monsters. It's done. We hit enter, and then MonsterCombat will launch us right into it. So here we go. And monster battle, Mothra versus Godzilla. So Godzilla has 200 health, Mothra has 7. Looks like the odds are very much against Mothra. Poor girl. Oh my gosh, she's down to 20 health, and Godzilla has 84. This battle's rough. Oh, she got negative 20. Post-mortem humiliation. Oh man, it's less than 0. Godzilla won this tournament with extreme prejudice, I'd say. Poor Mothra, poor girl. But again, we could, with another if plot, if we were to say, well, basically we'd have to say, look, if Mothra's health minus the damage is less than 0, a negative value, then simply set Mothra's health to be 0. So that would be an easy one line of code if we wanted to get rid of that negative value. But in this example, we'll just call it post-mortem humiliation. So Mothra, she died at 0, but then negative 20, Godzilla in his rage, he went over and stomped on her poor defenseless corpse or something. How weird is that? But maybe not the best example, but we'll look at how to code around that in later examples, okay? So hopefully this video, I can hopefully make it an hour long or less, was a good introduction to classes. And as we go through different projects and games and examples, I hope that the concept, things like encapsulation and inheritance and reusing code and an inheritance hierarchy will become more clear, and that you will see the usefulness of classes in your projects and in your scripts.